to add these rational expressions, but I noticed that they're not the same thing on the bottom. They have different denominators: 3x squared plus 2x minus 1, 3x squared minus 10x plus 3. Now I'm just going to be straight up honest with you. These problems take quite a bit of work to solve these. The first thing I want to do is factor these. So I'm just going to come down here and factor them. 3x squared plus 2x minus 1. So to factor these, I take the first and the last term. 3 times 1 equals 3. And I figure I have to subtract to get 2. So 3 divided by 1 is 3. When I subtract those, I do get 2. So I'm going to bring down the 3x squared and the sign after it. The biggest one of these has to come first and the letter with it. So I have a 3x, but I want a 2x, so that 1 has to be a negative because those two have to add up to the one that you just split apart. And then bring down the last term. Put parentheses around the first two. I have a 3 and an x in common. So I have a 3 and 2 x's. I took a 3 and an x out, so that's an x left, plus 3 divided by 3 is 1, and I took the x out there. And write down the sign after the parentheses, and these have a 1 in common. So that is x plus 1 and 3x minus 1. Okay, so 3x squared minus 10x plus 3. And if you're not familiar with this type of factoring, I do have another video called Factoring a Quadratic with Leading Coefficient Greater than 1, and that's what you need to look at. So you take the first and the last and you multiply them. So I want the factors of 9 that when I add them equal 10. So 9 divided by 1 is 9, and that adds up to 10, so that's the right combination. So you write down the first term and the sign after it. Biggest one first. So I have a negative 9, but I want a negative 10, so that one also has to be negative, and write down the last term. Parentheses around the first two, I can divide by 3, and I have an x. So a 3 and 2 x's, I took a 3 and an x out, so that's an x left, minus 9 divided by 3 is 3, and I took the x out. Bring down the negative sign after the parentheses. Now on these, 1 and 3, there's not a common factor, but you can always divide by 1. So if you don't have anything in common with these two, you have to put a 1. So that's x minus 3 times 3x minus 1. All of that to get my LCD. My LCD is one of each family. So I have a family of x plus 1. I have a family of 3x minus 1. And I have a family of x minus 3. This 3x minus 1, I already have it listed, so I don't put it again. I don't list it again. And we are only halfway done with our problem. And I think I'm running out of room. So I'll come over here and then I'll erase it if I need to. So I'm going to write each one of these vertically. So let me go ahead and just get rid of this next problem because I need to make space for myself. Sorry about that. Okay, so I'm going to write each one of these original ones vertically. 1 over 3x squared plus 2x minus 1 and 2 over 3x squared minus 10x plus 3. However, when we factored that, this one was x plus 1 times 3x minus 1, and this one was x minus 3 times 3x minus 1. So I'm going to come over here and put the common denominator, which is my LCD. So I've got x plus 1, 3x minus 1, and x minus 3. And that's my LCD, so that goes on the bottom of each fraction. That's what I want. So here's what I want, here's what I have. So you got to find out what you're missing. So on that first fraction, I'm missing the x minus 3. Whatever you're missing goes up top. And then you distribute. 1 times x is 1x. 1 times negative 3 is negative 3. We're going to do the same for the next fraction. Figure out what you're missing. We are missing the x plus 1. That goes up top. 2 times x is 2x. 2 times 1 is a positive 2. So you keep your common denominator that you wanted all along. Do not multiply it back out. Leave it in parentheses just like it is. And the numerators you put together. So for my x's, I've got 1 and 2. That's 3 x's. And for my numbers, negative 2 constants. Negative 3 plus 2 is negative 1. Okay, here's the situation on this one. You now notice that you have a family on the top that's exactly the same as one on the bottom. And here's the rule. If you have a fraction that top and bottom are the same, they cancel each other out. So with families, you can only cancel the families out if they're all the same. That means there's nothing left up top for your answer. And if there's nothing left up top, you have to put a 1. So let me make myself some room here. As you can see, these problems are really involved. And then I have an x plus 1 and an x minus 3. And that one's finally finished. It takes a long time to do one of these problems. I told you from the beginning, I'm not going to lie to you. Alright, so here's what we did. I'm just going to come over here and start factoring. 2x squared plus x minus 28. First times last. 2 times 28 equals 56. I want to subtract to get a 1. So 7 times 8. When I subtract those, I get a 1. If you don't know it off the top of your head, you've got to go down the list and just start dividing until you find it. So write down the first number and the sign after it. Biggest factor first. I have 8x. I want 1x, so I have to subtract 7x. And then bring down the last term. Parentheses around the first 2. I can divide by 2, and they have an x. So I have a 2 and 2 x's. I took a 2 and an x out, so that's an x and a plus sign. 8 divided by 2 is 4. I took the x out. Minus after the parentheses. Between 7 and 28, I can divide those by 7. So that one, when I factor it, is x plus 4 times 2x minus 7. Factor the next denominator. 2x squared minus 9x plus 7. First times last, 2 times 7 equals 14. I want to add to get 9. So that would be 2 times 7 because 2 plus 7 is 9. Write down the first term and the sign after it. Largest factor that works comes first. I have a negative 7. I want a negative 9, so the 2 also has to be negative. And copy down the last term. Parentheses around the first 2, they have an x in common. 2 and 2 x's, take the x out, so that's a 2x left, minus 7x, take the x out, so that's a 7 left. Bring down the negative sign. Between 2 and 7, they don't have anything in common that you can divide them by, so you have to put a 1. So that's 2x minus 7 times x minus 1. So my LCD is one of each family. I have an x plus 4, 2x minus 7, already got the 2x minus 7, x minus 1. That's the LCD that you want. So the original fractions were 9 over, I'm just going to go ahead and instead of copying this down, I'm going to write down what it was when I factored it. X plus 4 times 2x minus 7. And this negative goes with the 3. So negative 3 over, when I factored this one, I got this 2x minus 7 times x minus 1. That's what I have in the original problem. Here's what I want. I'm afraid I'm going to run out of room over here too. Okay, so I want my LCD. x plus 4, 2x minus 7, x minus 1. X plus 4, 2x minus 7, x minus 1. That's going to be the LCD in my answer because that's my common denominator. Now in the first one, x plus 4, 2x minus 7, I'm missing an x minus 1. The reason I cross those out is to see what I'm missing. I probably shouldn't have done that. Let me redo that here. Let's check it. 2x minus 7. I'm missing an x minus 1. 9x. 9 times negative 1 is negative 9. So that's a 9x minus 9 here. And this one, 2x minus 7 and x minus 1, I'm missing the x plus 4. So negative 3x minus 12. Okay, so 9x take away 3x is 6x. And negative 9 and a negative 12 is a negative 21. And I want my common denominator, but I just ran out of space, so let me rewrite it down here. 6x minus 21 over x plus 4 times 2x minus 7 times x minus 1. Now 6x minus 21, I can actually factor that. Let's come over here. I can take a 3 out and I get 2x minus 7. So I need to do that. So 3 times 2x minus 7, common denominator, x plus 4, 2x minus 7, x minus 1, families cancel. So the 2x minus 7 just canceled. So my final answer is 3 over x plus 4 times x minus 1. All of that, and that is the answer.